Welcome students to 11 Science Semester 2. So let's start the chapter number 1, which is Dynamics of a System of Particles. Here the first word comes dynamics, which we have already studied in the semester 1. So what is the dynamics? It is the branch of physics in which the motion of the particle is studied without its reason. So in this particular branch, we will only study the motion of a particle, but we will not consider any reason that why such kind of motion occurs in this particular particle. But in the semester 1, we have only studied about the motion of a single particle. But here we will consider a system of particles. So what is the advantage of studying a system of particles instead of studying a single particle motion? So see, in this particular system of particles, we can have information about a many particles by attending a single theory. So, in this particular chapter, which topics we are going to discuss? So the first topic we are going to discuss is the center of mass. What is the center of mass? That will be clear in this lecture. We will also consider the center of mass for two different cases. Which two different cases? The first case is for a system of two particles. And a system of n number of particles. So what is the application of using this theory of n particles? So see, here we have studied the center of mass of only two particles, and in this particular case we are going to study about n particles. So this is the generalized theory. So now you have the theory of n particles, and if you want to find out the center of mass for 3 or 4 particles, then you just have to put or substitute the value of n as 3 or 4. So this is the application of using the system of n particles. Some more thing we are going to discuss about center of mass. Of a rigid body. Now what is the rigid body? This is the new word for you. That word will be clear in this chapter. Now, using this theory, we will study the kinetic theory of system of particles, and in that we will obtain the conservation law of linear momentum only. But first of all, let me discuss center of mass of a system. So this is the article number 1.2 of your chapter number 1, center of mass of a system in one dimension. We will start this particular theory by considering this figure which I am going to draw below. So here I have given you the figure of one dimension. See, I have written only x-axis and it is in the positive direction. This O is the origin, and with respect to O, I have considered a system of particles with two particles of different masses. The first particle is having mass m1 and the second particle is having mass m2. So these are the two particles which are at different distance. The distances are given as the particle with mass m1 is at distance x1 from origin, and the particle with mass m2 is at distance x2, as you can see clearly from the figure, and this distance is also with respect to origin. Now see, one new thing which are going to see in this figure is capital C. Now, what is this C suggest? This C is nothing but the center point of mass m1 and m2, which is at distance x. From origin at distance x, there is a point C exists. So, here the C is the midpoint of particles m1 and m2. Now, if I want to find out the center of mass, of the system, here I will consider the given system. So, the center of mass is given by the value x, and here the x is given like the first particle mass m1, its distance from origin is x1. In addition to that, similar for second particle m2 x2, and the whole term is divided by the total mass of both the particles. So see, this is the first theory which we have studied in the introduction. This is the center of mass of two particles, but here we have considered only one dimension. But which are the quantities? These are just the symbols. It has no meaning until and unless you define them. So I am defining them. X is equals to the mass weighted average position. See, each word has its specific meaning. The mass weighted. So see, here the mass is taken. Average position. We have considered the average position by taking the distances of particles m1 and m2 of x1 and x2. Similarly, if we move further, then there are some different quantities. Here if we consider one case, that if both the particles have same mass, so I am generally returning as m1 is equals to m2 is equals to small m. So our equation for x. Therefore, x is equals to mx1 plus mx2 divided by m plus m. So the final answer will be, here the m will be common. So it is x1 plus x2 inside the bracket. In the division, it is twice of m. Here m are cancelled out. So the value of x is equals to x1 plus x2 divided by 2. So this is the most important result for having the equal masses, and from this I can write one statement which is more important as far as your SQ test is concerned. The center of mass, because X is the center of mass, of the two particles of equal masses lies at the center. Now see, the center means the point C which we have seen in this figure. At the center between the two particles. So the distance we can write as x1 plus x2 by 2, which equation we have obtained. Now, so this is the just the ending of, we can say, a two particle theory, but if we want to find out for n number of particles, so which particles I can consider? So this journey is for n number of particles. So here my particles are of the mass m1, m2 up to so and so mn, which are lying on x-axis as similar to this figure. At a distance, so the distance are, the m1 particle is at x1 distance, the particle of mass m2 is at x2 distance, up to so and so. The particle with mass mn is at distance xn from the origin O. These all distances are with respect to origin. So, the center of mass for this particular system, therefore, x is equals to m1x1 plus m2x2 plus so and so mnxn divided by the total mass. So m1 plus m2 plus so and so plus mn. Now see, I can generally write this addition into the type of a simple summation. So x is equals to sum over I, mi, xi. Yes, you can substitute the value of I from 1 to n. But at present I am generally writing, and at the below it is summation over I, mi. But here the one thing you consider, this is the total mass. So I am defining this total mass as capital M. So this capital M I can substitute in this equation, and my final equation for center of mass of a system of n particles. So this is sum over I mixi divided by capital M. So this is the final equation. But it is not the ending of this journey. We have only considered this particular theory in one dimension only. But there is existence of two dimension, three dimension. But now you think, if we consider in two dimension, then there is only change in the direction or the value of x only. So it is better that we should go for directly three dimension theory. So let's go through the three dimension.